Hello, this is Aaron with iBoard Repair, and today I'll be working on an iPhone 16 Pro that was run over by a car. And this is the condition of the phone now. It has no back housing, no back glass, and it has no front screen. And I've done a little bit of testing to this device already, and I've seen that the amperage draw looks like this phone is booting, but when I put a screen on it, I see no image. So I suspect this phone has no image, and actually I know it has no image, and I'll show you why in just a moment. Let me show you what I've found so far. So here is a battery connector. And if I take my DC power supply probes and I touch them to the battery connector, and then I press the power button, we'll see the amperage draw start moving on here. And it will stay here for a moment, but then it will move past it, and that right there looks like it's booting to me. And even if it's not booting, it's at least trying to give the Apple logo. So I should see image when I see this type of amperage draw. If I put a screen on here, I do not see image. I've already tried. And when you don't have image, the first thing you want to look at is the connector. So this is the display connector where the display will plug into. And it has a new design from previous models. There's pins very close together on this one. So there's like a whole row on this side, and then there's a whole different row on this side. And when you're trying to measure these pins, it gets a lot harder to do. There's a lot more to measure, and they're a lot smaller, so you have to use a different technique rather than using your probes, because the probes are not small enough to do it. So I use tweezers. I'll grab my probes with tweezers like so, and then I can use the point as my new probe. So this is the connector that we're looking at, and as you can see, there's a lot of pins. Normally there's only one row of pins and another row on the other side. In this case, we have a row here, row here, row here, row here. So I measured all of these, and these were all measuring fine, and it was when I got to this pin here that I saw something abnormal. So again, I used tweezers for my measurement. So this first row was what I measured first. 04, ground. Yeah, so I did that whole row, and then these ones were the other one, so it was the third one on this side, and it's easier to measure it from here, I think. Yeah, so it's this one. 1, 2, 3. Here, this 15. This is not what I was expecting to see. So the first pin is that 0.8 that we saw. This second one is the 0.5. And this third one is showing 1.5. Those corresponded to these three. So we saw 0.8, it's giving us 0.7, that's close enough. I believe we saw the 0.5 here. This one was showing 1.5 when we should only getting 2.27. So it says 276, it would be 0.27 on my multimeter. So what is this pin? It is 1v8 touch display. So it gives us touch, it gives us display, most likely. So I didn't measure any of the rest of these yet, so something else may be wrong, but this is definitely wrong. So I can just start with this problem and see if this will be the only issue. And it may be, it may not be. I have a few reasons to think that. Okay, where does this line go? So this is the other side of this board. If you just flip it over, this is what you would see on the other side. And we have a filter here, and this filter does a lot. It's my PP1V8S2 line. So that powers all types of things. I believe that's even my RAM line here. But there's a few things to note. One is that on this side of the line, it goes through the interposer. And I've seen already on this model that the interposer can separate from the board that it's attached to. So there can kind of be like a gap between this board and this interposer. But I would probably see OL if that had been the case. I'm not seeing OL, I'm seeing a 1.5. So that sounds more to me like maybe this filter has started to die, and that will be best case scenario. And a reason I know the rest of the line is okay, so on this side of the filter, this is the line we're looking at, the 1v8 touch display. This side is the 1v8S2 that does a lot of other things. But this filter, it's going to have the same diode motor reading on both sides of it. So we know we're supposed to have the 0.27 on this side, but we saw that 1.5, so way, way off. But on this side, everything should be the same as well. And I notice we have a connector over here, and this gives us a diode motor reading of 0.28. So that's the same line as our display line. It's just going through a filter. So we should have the same diode motor reading. So if I have 1.5 here, if I have 1.5 here as well, the other side of this filter, then the entire line's messed up, because this is a completely separate board. This one attaches through the interposer to this board. I've already measured this line and I saw that I have 0.28. So I know this line is normal, and that means that almost everything else is also going to be normal over here. I do believe that should also even mean my interposer is normal. I think so. So I have a heavy suspicion that it's just this filter that's bad. I will have to split the interposer, the sandwich, the layers of these boards in order to see this. But I'll show you this measurement right now to see that it's good. And then we can go ahead and split this and see what we find. So we just measured this third pin, and it was that 1.5. So that goes through the interposer here. It's hard to see. It goes through the board, through the interposer, into this other board way over here. And it connects to this line as well on the other side of that filter. And if we measure this line, we do get the normal 0.29. So that tells me most of the lines should be okay, and I think it's going to be the filter. Hopefully that's the only issue. This phone was run over by cars, so it had a lot of damage, I'm assuming, but maybe it just got a voltage spike to that line and blew that filter, and if that's the only problem, then we're going to have data very quickly. So I'll pull this board out of this housing. We'll put it onto a heating platform and we can split these boards. So I've got the board here. And for this model, most heating platforms are going to have the CPU and NAND board facing down, which is a little different. So because of that, I'm pretty heavy with the hot air on the top board instead. That looks great to me. It's pretty subtle, so I don't know if anyone else would be able to tell, but I'm pretty sure this is the filter that I thought went bad, and it looks a little discolored to me. So I think I'll have the normal 0.28 reading on one side and then the 1.5 reading on the other side of this filter. I can verify that very quickly and easily. So one probe on ground, the other one touching this filter. 1.2, 0.29, watch. 0.2. So both of those are a little bit low, and that's just because this board's actually still hot, and that brings that reading down. But yeah, that proves it. So this filter went bad. And like I said, this is directly on the other side of the connector here. So it was starting at the inward one, the one that's like facing that way. 1, 2, this third pin goes through this filter, through the filter into the rest of the line, and this filter went bad. This was a very heavily physically damaged phone, and I guess it's not entirely uncommon to see this type of issue, but I haven't seen it on this model yet. But I haven't seen too many 16 Pros yet, so who knows what we'll see. So I can just add a blob of solder to the top of this, and that should actually fix it, but it's probably safer and better to just go ahead and fully replace this filter. I'm pretty sure I have a donor board I can use, so might as well. And just so you can see, this is what I was just measuring. So this side was high, like 1.2, this side was at 0.2. Should be easy to replace, and this phone should be working. I can reball these layers if I want, and this phone should work again, but this is just data recovery, and he doesn't even have a screen. He doesn't need the phone working, he just needs the data. So this will just go into my testing jig in order to pull the data. Let's see if I can get a little bit of leaded solder on those pads. Even this tip is not small enough to get in there. I have another smaller one. I do still have a donor here. It appears to have moved into place. I can wait for it to cool and then clean it up, and then I'll measure the line on the other side. And if I measure this line now, I should have a normal diode mode reading on it, which was 0.28 or 0.29. So starting from this like secondary one, 1, 2, 3, 0.35. Not exactly normal, but I'm sure that's probably fine. Let's measure over here. 0.35, 0.35. So I can put this into a jig now, and I should be able to use the same top board, though actually I don't think that actually matters whatsoever on this model. I think NFC's on this board. Anyways, I'll just try to reuse this board just because. So I'll clean it up a little bit, and let's put this into a jig and see if it's giving us image now or not. I think it will. It's my donor battery. And we have an Apple logo. So this one wasn't too difficult. I was able to determine that it looked like the phone was booting by checking out the DC power supply amperage draw when I prompted the phone to boot when I first got the device. That led me to believe that the phone was booting. So I tried to put a screen on it, and I saw that there was no image on the screen. So booting and no image leads you directly to the image connector first. So I started measuring the connector itself, and I noticed that one of the lines was giving me the improper diode mode measurement. It seemed way too high. It led me to believe that there's possibly a bad filter on the inside of the sandwich. So pulling the sandwich apart, I was able to replace that filter, and this phone is giving me image and the data is accessible. So thanks for watching this video. I hope you stop by again. Bye.